Solutions and colloids. So we know what is a solution, where we have a solute dissolved in a solvent and it should be transparent. You should clearly be able to see through it. But then there is something called a colloid, also known as a colloidal dispersion. What is a colloid? We can say that milk is a colloid, or we can even say that blood could be a colloid. Well, in a colloid, you have the size of the particles that are trying to dissolve themselves within the solvent, but they are just too large. The size is between 1 nanometer and 200 nanometer. In a solution, in a true solution, the size of the particles are smaller than 1 nanometer, and so they do not scatter light. When you have a flashlight aimed at a solution, the flashlight would be able to go through it without the light being scattered. On the other hand, in a colloidal dispersion or a colloid, light can just not pass through it. Instead, it gets scattered, and so you do not see light coming out through it, and similarly you are not able to see through it. It is identical in a solution in a way that it is mostly uniform. So in an actual real solution, you have homogeneous distribution of solute in the solvent. Similarly, in a colloid, you have near homogeneous distribution. Since the particles are too large, it's not exactly homogeneous, but otherwise it appears homogeneous. For example, milk appears homogeneous, doesn't it? The homogenized milk actually is very homogeneous. Yet it's not a true solution, because the size of the particles in milk, some of them, especially some proteins, are very large, larger than 1 nanometer, giving birth to a colloidal dispersion. If you have a particle size that's greater than 200 nanometer, then they will eventually precipitate, and then we call that a suspension. But sticking with colloids, here is how we can find whether you have a true solution or a colloid, and that's through something known as the Tyndall effect. The Tyndall effect shows the ability of a colloidal dispersion to scatter light. As you can see, on the left you have true solution and it's transparent, while on the right it's not a true solution, it's hazy, and light is being scattered. That's what makes it hazy. Another example of a colloid is fog. During the day, during your travel somewhere in a car, you may see that it's foggy, and you may turn on your headlight on your car, which only makes things more difficult, because now the light is being scattered everywhere and you cannot see what's in front of you depending on the amount of fog. So a fog is basically a gaseous colloid, while here what we have here are liquid colloids on the right.